guys. So today we are going to look at some properties of logs, how to expand them and condense them using some properties that you saw last year in Algebra 2. So the first thing we're going to do is we're going to take two logs and we're going to condense them together. This is going to come up more often whenever we do solving equations here in a few days. So in order to condense logs, there's a few things you want to look at. You want to look at the operation that's happening between the logs. So if two logs are being added together, then you can take the two arguments and you can multiply them together and write it as a single log. So this first one can become log of a times n. All right, another property of logs is if you have a number out in front multiplied by the log, you can move that to become the exponent on the argument. So we'll go ahead and do that first on this one. So this number out in front can become the exponent here. So this would become log 9 plus log 2 to the third, which is 8, minus log 3. Now, using those same properties we just did, two logs that are added, you can multiply the arguments together. And then the last property is if you have two logs that are subtracted, then you can take those arguments and you can divide those arguments. So in this one, since they're subtracted, we can write this as a single log and divide just the arguments. So notice we're just dividing what we're taking the log of. We're not actually dividing the actual logs. So this would be 72 divided by 3, which we can actually find that value. So this would be the log of, 24. All right, so again, looking at the next one, we'll start by moving the numbers out in front to become exponents. So 1/2 becomes the exponent on the x, 2 becomes the exponent on the y, 3 becomes the exponent on the z. Now remember what 1/2 as an exponent means. 1/2 as an exponent means the square root of x. So then I'm going to move each of those exponents. And then if we're subtracting, then we can divide the logs. Another way you can look at this is if it comes after a minus, then that's going to be in the bottom of the fraction. Okay, so that argument will be in the bottom of the fraction. So this would be log, square root of x would be at the top, and y squared and z cubed will both be in the bottom because they come after a minus sign. All right, looking at the next one. Now, a really common mistake is a lot of people see this and they want to distribute, okay? We cannot distribute a log to its argument, okay? It's not the same thing. That's why we have those properties there. If we could distribute it, then we wouldn't need those properties, okay? Natural log of a plus natural log of b, that is not the same thing as the natural log of a plus b. Okay, using those properties we just did, that's the natural log of a times b. So be careful not to distribute a log to its argument. All right, so let's use those same rules. That 2 can become the exponent on the c. So that becomes c squared for the argument. The two that are added, I can multiply together. So I would do a plus b times a minus b. I can simplify that. That's a difference of squares. So that becomes a squared minus b squared. And then the subtraction of the logs becomes division in the argument. So this becomes a squared minus b squared at the top and c squared at the bottom. There is nothing we can do to separate the plus or minus within the argument. It just stays the way it is. All right, so now we're going to go the opposite way. So we are going to take logs that are already together and we're going to expand them. So one thing to remember, if you see multiplication within the argument, that can become separate logs that are added together. So this is 3 times y times x to the 4th. So I can write that as 3 separate logs that are being added together. What I also can do is I can use my rule about this 4, take that 4 and move it to the front. And now this is going to be fully expanded. All right, let's look at the next one. So again, we can start. If you see division, then whatever comes at the bottom of the fraction is going to have to be after a minus. So this will be minus natural log of y. Then this is 5 times x to the 7th. Now notice the 5x both do not have that exponent. It's just the x that has it. This is 5 times x to the 7th. So this becomes natural log of 5 plus the natural log of x to the 7th. And then using that log property, I can take that 7 and move it to the front. All right, again, there's a couple ways you can do this last one. But remember, anything that's in the bottom of the fraction is going to come after the minus. So this will be log base 3 of 5 minus log base 3 of 12 minus log base 3 of x. Another way you could have done this, you could have said it's log base 3 of 5 minus, and then done some parentheses, and then you could say that those two logs were added together because they're both in the bottom. No, either way works. I think the first way is a little bit easier because we just remember if it comes after a minus, it's in the denominator of the fraction. All right, let's look at the last one. So square root. So we have to remember what square root means as an exponent. So square root as an exponent is 1/2. So this is the same thing as x minus 1 over x plus 1 to the 1/2 power. Well, then using those exponent rules, I can take that 1/2 and move it to the front. And then because there's division in the argument, I can separate that into two logs that are subtracted. And I'm done. All right, so now we're going to look at two last properties, and these are the inverse properties. So these look a lot more complicated than they actually are. What you're going to notice in these properties is there's one of them that's a log and one that's an exponent. So if you see log and you see that the argument and the base match, if the argument and the base are the same thing, then your answer is just whatever that exponent is. The other property is if you have a base raised to a log of the same base, then the argument is just your answer. So let's look at this first one. This is 8 raised to log base 8. So because those 8s match, my answer is just 4. All right, let's look at B. 5 raised to the log base 5. So my answer is just the argument, which is x minus 2. Log base 7 of 7. So again, this is the opposite one. But again, the base and the argument match. So my answer is just the negative 3x. All right, and now the next one, that one's a little bit trickier. It's harder to see because you don't see the base. Now remember, natural log has a base of e. So the base and the argument already match because ln means log base e. Okay, ln is the same thing as log base e. Well, since those e's match, my answer is just 5y. All right, again on e. You can't really see it, but ln has a base of e. Because those bases match, my answer is just 20. So the last ones are just a little bit trickier. It's the same idea though. So right now, the 8 and the 2 do not match. But what I can do is I can rewrite it so that they do. Because I can rewrite 8 as 2 to the 3rd power. Well, I'm not quite done yet. Okay, I can't just go ahead and say my answer is 7. This 3 that's in front of the log becomes the exponent on the 7. So this becomes 2 to the log base 2 of 7 to the 3rd. And if you didn't have a calculator of 7 to the 3rd, I mean, you could, I guess, just do 49 times 7 over here on the side. That one's a little bit bigger than we'd probably give you guys without a calculator. But that one should be, is it 343, I believe? Let's see, 3, yeah, 343. All right, the next one's also a little tricky because you can't really rewrite 8 as 4 to the something power. But on this one, if you look at the exponent is log base 4 of 4. We know what log base 4 of 4 is. Log base 4 of 4, if I just work that out on its own, 4 to the x equals 4, log base 4 of 4 is the same thing as 1. So this is just 8 to the 1st, which is just 8. All right, then the last one, again, the bases match, but we have this 3 out in front. So that 3 out in front has to become the exponent on the 5. So that becomes 5 to the 3rd. ln has a base of e, so those match. So it's just 5 to the 3rd, and 5 to the 3rd is 125. All right, so that is it for today with log properties. We're going to look at solving equations next class and use some of these properties again.